Hello everyone. So in this video, what we will demonstrate is what happens when you send data using a queue to a thread that is equal or lower priority task than you. So I have a producer that's going to send an item, and the producer is going to send an item over to a queue from which a consumer thread is going to receive on, but the consumer is going to be same or lower priority. So we have producer with low priority, consumer with low priority. So what will happen is the producer, if assuming producer runs first, producer is going to say, I'm about to send an item. And when the producer sends an item, there's not going to be any context switch here. So we will look at this behavior. So let me erase these comments and start over. So let's see which task runs first. So consumer happens to run first. Now, producer and consumer were both equal priority tasks, so the FreeRTOS can pick either one of them to run, and it doesn't violate the scheduling behavior. In this case, consumer runs first. Consumer says, I'm about to invoke xQsend. Consumer calls xQreceive, and there's nothing in the queue, so this is context switch number 1. There is nothing in the queue. So producer will start to run, right? The producer starts to run now. And unlike this is the key difference from an earlier video. So producer says, I'm about to send an item, calls xQsend, but there is no context switch here. So there's no context switch here because you sent an item to a queue and the consumer was blocked on the queue, but he is equal or lower priority. So producer is going to say, I'm about to send an item, and it's going to go on over to item was sent. And there's not going to be any cooperative context switch in between. The context switch is only going to take place after printing the line. So this is context switch number 2. Which is that consumer was blocked and will start to run. Consumer got an item, it woke up because the item was there. We'll say item is received. We'll circle back around and say about to invoke xQreceive and then get blocked again. So let's double check our assessment. Consumer says, I'm about to receive an item. There was nothing in the queue in the first place. Gives a chance for producer to run. Producer executes both lines, about to send an item, and item was sent, and there's no context switch or no cooperative context switch happening because the consumer is equal or lower priority than you. If consumer was higher priority, like the previous video, you will see a context switch here. But consumer is equal or lower priority, so the producer will print both lines back to back. Then it will be print line like here. When producer goes to vtask delay, cooperative context switch happens. Consumer gets unblocked. You just unblocked consumer by putting an item. And then the consumer circles back around to say, I'm about to invoke xQreceive API and waits on the next item at this point. So in summary, the real-time scheduling will use the event system to wake up tasks that are higher priority and immediately start running them. But if you send an item to somebody of equal or low priority task, then this context switch doesn't take place because the other guy is not higher priority than you. Thank you.